Hello everyone, welcome back again to Plaxis 3D Shallow Foundation course from theory to practice. This is lesson 8. In this lesson we are going to investigate the bearing capacity of shallow foundation on loose sand or cohesionless soil using Plaxis 3D. Create a new project. We give a title like foundation on loose sand at 0 also, and in 𝐸max 3 meter also. So it is the same. The only difference is that the center of the axis 0, 0, 0 will not be located at the center of our soil model. So I actually prefer like this one. I want the coordinates be located on the center of our soil geometry. That's why I mostly do like this, and there will not be a difference between results if you choose the other method. Okay, we defined the soil contours, and right now we defined a borehole. So we create borehole, and we can see there is a problem. We can go to option and visualization setting, and we can put this one as 0.25. so right now we can create a borehole in here. Actually we can create the borehole at any place on the soil soil contours. So we click on here and we add one soil layer. As we say, the height of the soil layer is 4 meter. I put 4 meters from the top and 0 at the bottom, and we will not consider the water table also in this example. So we have to define the material as well, and we assign the soil to the borehole. Okay. So we go to the structure mode and we go to the top, which is 4 meters, and we define a surface for to define the foundation. As we say, the foundation or the footing is 0.5 meter by 0.5 meter, so the coordinates will be like that. These are the coordinates of the foundation. Okay, and we have to convert this surface to plate. Also we have to define the footing 0.5 meter by 0.5 meter. This is just an identification and the title or a name of the material. Assign the footing material to the plate. Okay, so right now we define the footing as well. Define 3 phases in this example as we did in the previous examples. The first one will be initial phase. The second one will be construction of footing, and the second one will be applying the loading to the foundation. We will also reset displacement to 0 in this stage. So in the initial phase, choose a point at the center of the footing for defining the load settlement curve after the calculation. So we click on select points for curves. Okay, the coordinates of the center of the footing is 0, 0 and 4 meters. So we will choose a node which are defined as a plate. We will choose this one. This is the nearest node to the center of the footing. We click update. So right now the problem is ready for calculation, and we can save also before we start calculation. And we save in our Plaxis 3D Foundation course in lesson 8. Paste. Okay, so now everything is ready and we start the calculation. So since we defined a refinement around the footing, and we also used a fine mesh, so you have to be patient, because this tutorial and this example also maybe take a long time, and depends on the computer which you use. So you have to be patient actually. Okay, so this is a deformed shape of the model. We can see that it becomes like that, and this is not a true scale. We go to the view, scale, and true scale, like that. So we can see that very small patches also happen near here, because the foundation settlement is very much according to the foundation width. So we will go to the load settlement curve, click new, and in the X direction we choose the M stage. In Y direction we choose the settlement or displacement in Z direction. Similar to the previous examples, we will just export or import data from the loading phase. Okay, and we will export this data to the Excel spreadsheet. Okay, so we go to here. This is in the case of loose sand. We copy the data in here, and we remove this one, and we copy these two columns to here. We remove these two columns, and this column is load, and this one is settlement. So in here the load is in kilometer per square meter, and the load is in millimeter. So we have to for the load we have to multiply the M stage by 120, and also we have to multiply the settlement by 1000 to convert it from meter to millimeters. And so this is a load settlement curve for the footing resting on the loose soil. And how to we can change the name of this series also. We can change it to loose sand, or maybe we can footing on loose sand. So we estimate the ultimate bearing capacity from these settlement load curves. As the previous examples we did, we drew a line in here. Okay, so we can say that this point in here is the ultimate bearing capacity of the foundation. Maybe it is, sorry, maybe we do like that. Okay, so this is 100, 104, 108. It's about 100. Q ultimate is about 110 kilonewton per square meter. So now we will calculate the ultimate bearing capacity of this foundation on loose sand using 110 according to the finite element method using the Plaxis. As I said before, this lesson, and I hope it was beneficial, and see you in the next lesson.